Alright, in this video I'm going to be talking about GRE tunnels and more exclusively about a recursive routing error. I'm not going to get too into detail about GRE tunnels. They are a form of a layer 3 VPN. They can connect two end devices over a public network or any network really, and it seems like two endpoints have a direct connection, but they do that through this tunnel, and it creates a logical direct connection rather than a physical one. But sometimes when you are using GRE tunnels and using dynamic routing protocols, sometimes you'll get this recursive routing, and then you'll drop your neighbor, whether it be EIGRP or OSPF or some other type of dynamic routing protocol. So what is this recursive routing? Well, plain and simple, it is when the actual physical tunnel destination decides to take the tunnel interface itself. Okay, what does that mean? That means when we have, let me bring up the topology. When we have a topology like this, here's the cloud, and then we have router 1 creating a logical connection to router 3. Now, the way that we set it up is we have to have a tunnel source and a tunnel destination. So how that actually works is, well, how does router 1 connect to router 3? How does it, if it's going to take this logical tunnel interface, then how am I actually going to physically get it to the other side? This is where the tunnel destination and the tunnel source IP address comes into play. Now, if we actually look at this in a packet format, you'll have, your data here, and then we'll just package that. Then you'll have your tunnel interface IP address. So then this would be the 192 address, 168. I'm running out of room. 01. That'll be in there as the source IP address, and then the destination is actually going to be, 0.2. And we'll just go ahead and package that up. And then that is encapsulated with this GRE encapsulation, and it adds another layer 3 header. And then the new source and destination IP address is going to be these addresses right here. Okay? So the new source IP will be all ones, and then the destination IP will be all threes if it was leaving router 1 right here and going that way. All right. So when this recursive routing, it all has to go back to the routing table. All right. So let's go back to the slide real quick. So how can this happen? It's all about the routing table and how it learns of the tunnel destination. A big thing is, if you are going to be using the public internet, do I actually have a route to that physical, to the physical router's IP address? So normally when you set this up in the real world, you will use loopbacks on a router. Reason being, it never goes down. Only a software issue will make a loopback interface go down. So that's why you wouldn't use the actual physical IP address here. You can, but as soon as someone does a shut or unplugs the link or something, the tunnel is down. And also if you have redundant links to the internet or to this network, then yes, you could have that loopback address as the tunnel destination because it has multiple ways to get to it. All right. So let's take a look at router 1's routing table, and does it know how to get to 3.3.3.3? I already have the tunnel set up. This is the configs for it right here, and I'm running EIGRP through this tunnel, and I'm monitoring these networks here, 11.11.11.11, 33.33.33.33. All right, so let's get to router 1, and let's do a show IP route. And I have my directly connected networks, but I don't actually know, well, that's the 33 network, but I actually don't know how to get to the 3.3.3.3 network. Well, how is this working? Well, I have a default route. Normally, you should always have a default route pointing to your ISP. So, since I don't have a route to 3.3.3.3 on router 3 in this topology, then the tunnel will form because it's going to use this default route. And vice versa when we go to router 3. How does it actually get to 1.1.1.1? Well, it's going to have a default route. All right. So the tunnel's up, and if I do a trace route to 192.168.0.1, it looks like it's directly connected, one hop away, when it's actually more than one hop away. But that's how GRE tunnels work. Okay. So where's this recursive routing? Well, here it is. In our configs, we are connecting this GRE tunnel with these loopbacks on router 1 and router 3 via these IP addresses. What happens once the tunnel is established, that we advertise that into EIGRP, so we could dynamically monitor it. This is where recursive routing comes into play. And I have to do this quickly because I want to show you something. So let's go to router 3 and let's go to configuration terminal, router, EIGRP. Crap, is it 1? I think it's 1. 1. Hold on, let me do this. Do show IP protocols. Let's see here. It is EIGRP 1. Okay, cool. Let's do the network statement for our tunnel interface. Now, as soon as I hit this, I'm going to hop over to router 1 and see if I learn about the 3.3. Oh, no, I'm sorry. That's not it. 3.3.3.3. So let's see if router 1 learns of this loopback address via EIGRP in router 1. I got to do this quickly because I'm actually going to tear down my neighbor relationship. So I'm going to go hit enter. Boom. Show IP route. Look at that. Now I learned about this tunnel destination via EIGRP. I am no longer using this default route, my gateway of last resort. So at this point in time, when I'm sending these, what is this? Not hello packet. In EIGRP, it is hello packets, but I want to say these keep alives, or what the GRE tunnel is doing its thing to keep it up. It notices, hey, I have a better route to get to my actual tunnel destination configuration, and it's, all right, take tunnel 1. Well, that is a logical interface, and you can't directly send packets to a logical interface. That actually drops it. That's why there's the null interface, things like that, where packets are going to be dropped. So in EIGRP's world, it's like, okay, I actually have a better route to get to my tunnel destination, router 1. And it says 3.3.3.3. I actually have a route at this point in time. Let's take this logical interface, and then it drops the packet. And this is how you get the temporary disabled due to recursive routing. And then you'll get flapping, because all of a sudden now the routing table it'll lose, since I lose my neighbor relationship, I won't have any EIGRP networks. So it's like, oh, well, let me just use the default route. Okay. Once I use the default route, the tunnel interface will come up, EIGRP will come up, it'll learn about the networks, and it'll repeat this process. That's why I keep getting flapping right here. It comes up, it goes down, comes up, comes down. And it's all because of the routing table. So let me go back to my slide. Let's see what it is. Does it use a default route? Well, if it uses a default route, then learn about the tunnel destination via a dynamic routing protocol such as EIGRP that we use on the tunnel. then now the best route is to go through the tunnel interface itself, which is logical, and it will drop the packet. How do we fix this? Two ways. Use a static route. A static route is always preferred over any dynamic routing protocol by default as an administrative distance of 1. So that's one recommendation. Or two, do not advertise the actual tunnel destination IP in the routing protocol. Okay? So it all happened when the distant end started advertising the actual tunnel destination IP address into EIGRP because we want to monitor it. Well, let's say that's our requirement. We need to monitor our actual tunnel destination. Okay, fine. So what we can do is actually go to router 1 and create a static route for it. So we could do IP route 3.3.3.3, and it's a /32, and the next hop. Now this should come up, because if I do show IP route, how do I know about the 3.3.3 network? It's a static route, administrative distance of 1. So that fixed our error. And if we actually do the same thing here, and we add it to the dynamic routing protocol, router 3 will go down, but again, it's the same reason. How do I show IP route? How do I know about that network? Well, I was too slow. But again, it's because it's flapping. It's going up and down. I don't actually know how to get to that destination IP address. Then I learn it via GRP, and then again flapping. So we got to add that static route. Come up. Come up. Please? Please come up. Show IP route. Yeah, it should come up. Ping 192.168.0.1. Oh, there you go. Took a while for the tunnel interface to come up. And now our routing table looks the way it should. Now, what we can do actually, you would have to keep the static route below the dynamic routing protocol's administrative distance. So that's it. I hope this gave you a better understanding about recursive routing and GRE tunnels. The basic thing is, look at the routing table. How does it know about the actual tunnel destination? How does it know how to get there? And make sure that if you're using a default route, that you don't advertise the actual tunnel destination into your dynamic routing protocol over the GRE tunnel itself. All right. So that's what recursive routing is. I hope this was informative for you, and I'd like to thank you for viewing.